Hello there, and welcome to this tutorial video from unicourse.org. My name's Mike Lopez and I'll be guiding you through this session. Let's have a little look at what we're going to end up with. We're going to be looking at a basic circuit with a battery, a resistor in series, and two parallel resistors in series with that resistor. Ultimately, we'd like to check voltages, currents and powers in this little network. So let's make a start first of all having a look at all of these resources over here on the left and all the icons along the top. Now what you see over here on the left is a whole host of resources. At the top here we can see analog primitives. Primitives are just basic components. Passive components, most common, resistors, capacitors, inductors. Just click on one of these and you can see what it looks like in the view menu at the top here. What I could also do is actually drag it over if I want to include it in the circuit. Here it goes, left click, place it. It's asking for a value, I don't know, give it 1 millihenry, use a little m, 1m, click OK. It's in the circuit, and click on the Selector Tool to remove the next version of the inductor. I can move it round, and if I want to I can wire it in by grabbing the wire tool over here and sticking a wire in. That doesn't look too useful at the moment, but you know, that's the essence of bringing in components and wiring them into various places. So I'm going to select the whole thing and just hit the del key and it disappears. Okay, you can see a transformer here and other bits and pieces that you'll be using in many of your simulations in the future. Active devices, we're looking at NPN and PNP transistors. So these are bipolar types. NMOS and PMOS, okay, so these are metal oxide semiconductor, or MOSFETs as we call them, and there are other variants down here. You'll notice an op-amp up here as well, which is going to be used quite frequently in lots of your simulations in future. Waveform sources, okay, battery, voltage, current source, sine source, pulse sources, user sources that you can make up. You can have three-phase triangles and staircase sources. Okay, three-phase triangle, here you go, there's one of them. Righto. You can move further down. We've got more advanced things, function, Laplace. Okay, we're talking level 5, 6 here, so don't be too scared about all this stuff. Macros, subcircuits, connectors we can go into. You can get jumpers and diagonal jumpers, etc., things like this. Okay, and so that's enough of the analog primitives. This analog library here, you know, 99% of the stuff that's in there is reserved for the professional version of this particular application, but there are a few components that we can pick and choose and simulate. We can see those in future videos. Okay, the other half is the digital side of things, obviously very useful. AND gates, 2 input AND gate, here's a symbol, 9 input AND gate. Symbol tends to look a bit clunky, but you know, that's what it looks like and it's still functional, it works very well when you simulate things. Buffers, which is basically just an amplifier which keeps the gain at 1. Got inverters, or to a lot of people that's a NOT gate, and there's a NOT gate symbol for you. Got NAND gates here, NOR, or exclusive NOR, exclusive OR gates. And we can come down to tri-state gates. Tri-states are 0, 1 or high impedance, as you know. Edge triggered flip-flops, JK flip-flops, D-type flip-flops. These little guys we'll be using more often than anything else to build our more advanced circuits. Okay, and of course further down here you have a digital library. Again, most 99% of it is reserved for the professional version, but there are bits and pieces that we can use in future videos. And lastly, down here, the animation tools. You can have a meter. I can drag that meter over. I don't want to because it's going to destroy the circuit, which I've just noticed, by the way. has a wire missing, but don't worry about that. Let me just get the wire tool and left click and just drag over, let go. There you go, as if by magic we have our little wire back in. Okay, there's nice little other things in the animation section, like traffic lights that you can put in. Here's the 3 connectors for them. There are animated switches, single pole, single throw switch, a single pole double throw switch. Here's a symbol up here. 7 segment displays that you can have lots of fun playing about with. Okay, so there's the section on the left. Okay, over on the top here there are lots of useful icons. Let's have a look. Initially, you know this about this selector tool here, so when you have an annoying component following around your cursor, you just hit that arrow there and it disappears, and you're allowed to then select anything you feel like. I'm not going to go through each and every icon, only the more useful ones. Text tool here, so if you want to put headings in on your schematic or markers, or you know, record some note or whatever on your schematic, just click on that, put it into the area that you want to. Hey presto, you can change the font and the colour and everything. The wire tool we've already seen. Diagonal mode wiring, that's useful when you have that 3-phase circuitry in place. Here we can see drop downs for putting in your little bits of graphics, lines, ellipses, circles, rectangles, diamonds, etc. Here you can add in a picture. Very early on in this video I used that to add that photograph of me. We can move further over, and you know, here we've got grid text and attribute text. You'll see about those things later on. And you can look at node numbers as well. Maybe I could click on node numbers at the moment, and you can see there's node 1, here's node 2. By default, where the ground is being placed is node 0, and that's not normally shown. Okay, that's just inferred. So there are basically just 3 nodes in this thing, 0, 1 and 2. Okay, I can take those nodes off for the moment. When it becomes active, as you'll see later on, we can look at node voltages, circuit currents, and powers dissipated by various components. Okay, and this one is pin connections, which can be useful occasionally when you've got chips on board. Right, something else which is very useful is the grid. So at the moment I've got no grid selected. I tend to use graph paper a lot, and that allows me to lay out the circuit in a nice symmetrical fashion. Okay, when you're doing screen captures, it's always a good idea to turn the grid back off again, which I can do now. One of the very useful tools on this simulator is this thing here. It's called rubber banding. Now at the moment that looks like it's turned off, so if I was to maybe think of what to change this component, I made an error and I want to remove it. Because rubber banding is off, I can just lift the components out the circuit and hit the del key if you want to, and it disappears, and then replace it with something else. Let me do Control Z, bring it back to the way it was before. If I now turn rubber banding on, you know, the name suggests, you know, there's something happening in terms of sticking together, rubber banding, and you'll notice the wires, as I've raised this resistor upwards, have come up with it, so they are, if you like, they're rubber banded together. Okay, so very useful tool. Right, moving further over, we can see that we can zoom in, okay, or zoom out. It's quite standard on most applications. If you're trying to do a good screen grab, it's a good idea to do 100% zoom, so your circuit fills the screen, like so. Maybe a bit too much in that instance, but just bring it back down again. There you go. Another thing I'd like to discuss is this analysis menu over here. Okay, so left click on that. We can see a transient analysis. Now, That might sound a bit vague, but a transient analysis essentially has time on the horizontal axis. Okay, and that's quite useful for looking at most circuits. You know, you can look at amplifiers, you can look at digital circuits, all sorts of things. AC analysis, this one, rather than time on the horizontal axis, tends to have frequency on horizontal axis. So we're looking at things like low pass filters, high pass filters, band pass filters, Butterworth, Chebyshev filters, as you'll see later on in future videos, and also amplifiers as well. You want to look at the frequency response of various circuits. Okay, some of these tend to be used more often than not. Dynamic DC is what we'll be using shortly in this video. We also have dynamic AC. Yeah, you're looking at AC currents, DC currents, voltages, powers, whatever it might be. These two are quite useful. And we've got more advanced analyses down here. And there are also useful ones down here where you can probe various analysis, and again this video and further videos will demonstrate all of these resources for you as we move forward. Okay, so let's get on and get ourselves a clean slate. Here we are, and I'm going to try to draw that circuit for you. I'm going to start off with a battery rather than go over to the primitives over here. There's a quick way to find a battery, and there's one there. So left click, okay, pull the mouse down into the circuit and place the battery by left clicking. Now immediately it goes on in this pop-up box here and asks you for the voltage of the battery, and we put 12 in earlier, so I'm just going to type 12. No need to type V, just the number 12. So 12 volt battery appears there. Okay, now if I just zoom in slightly, what you can see here, let's move it to the left, it's got V1 or battery V1 and 12, meaning 12 volts. When I draw my circuit, I like to have the V1 along the top and the voltage below it, but that's just a personal preference. Another thing as well is I don't like to give tags of V for batteries or batteries in EMF or a voltage source, so it's always useful to double click on that rather than call it V1 and just backspace out and put capital E in there. And that's what I did in the earlier circuit that you saw. Okay, now I need a couple of, well, in fact I need 3 1K resistors. One of them is in series, so here it is. It's not exactly in the right place at the moment. I need to flip it 90 degrees clockwise. So if I hold down the left click and then right click once, that's a quick way to rotate. And here we have a dialog box asking us for the resistor value. Now I could type in 1 little k, and that would be 1000 ohms or 1 kilo ohms, as you know. If I wanted 1 meg ohm, this particular simulator is a bit fussy, it doesn't like a capital M, so you have to type in 1 capital MEG, 1 meg. Okay, well, we don't want 1 meg, we want 1k, so let me go back to 1k and click OK, and there's the resistor. Now by default the simulator assumes you want another resistor, so straight away you have one on your cursor. So move the cursor around. I'm not touching any buttons at the moment, and we have this thing there. So why don't I left click, right click, and I've got it oriented the way I want. It also assumes you want the same value as last time, which in this case you do. So it's got 1k up here, which is fine. So do that. I want another 1k. That's oriented the way I'd like it, which is good. So left click, place. Again, it assumes 1k, which is good. Put that in there. Now I've got yet another resistor on the cursor, which I don't want, so just go over and click on the Selector Tool there and it disappears. There is one thing missing apart from the wiring on this circuit. Of course, all circuits that you produce in MicroCap need a ground or an earth, so I'll place the earth about here. Now I'm looking for trying to produce a nice symmetry to this circuit. Again, let me click the selector. That's where the graph paper comes in handy. So click on the graph paper. Now I can move all the components in nice predictable squares. Drag all these over like this. It's not going to look identical to the other circuit, but that doesn't matter as long as it looks neat, that's fine. It was a good idea to have an odd number of squares between them so you can get to the center point. Doesn't look too bad. Why don't we get the wiring tool, left click, and then just let go for all this wiring. Maybe I'd like to wire this thing into there. Get the selector tool again, move this little guy over there. Okay, get some more wiring, bring that up there, bring it across, and because it's crossed in that fashion it assumes you want it connected. Okay, which it does, which is fine. Down here, left click across, move up, let go, left click again, and then finally I would like some more wiring from the bottom of the battery, move across, let go, left click again, push that wire into there, hit the selector tool, and I'm going to then have the earth pushed into there, and that don't look too bad. You might like to spin these around a little bit. Okay, that's just me maybe being a little bit fussy, but R2 has a value of 1k, and left click on these as we move them. R3 has a value of 1k, and of course this little guy here probably better looking like that. Okay, and that's pretty much the circuit that we had before. You'll notice I've got rubber banding on, which means the wires come with the components. Okay, maybe turn the grid off and left click there. That doesn't look too bad. Possibly a bit out of symmetry there. That looks a bit better. Okay, and that's how we construct the circuit. Now that we have our circuit built, it's time to simulate it. And I'm looking for voltages, nodes, currents through components, and powers dissipated by each of the components, including the battery, by the way. Okay, how do we do that? So we're going to move over to Analysis, move down to Dynamic DC, and we have a little pop-up box here for temperature, which you can change. It isn't going to make any difference in this one because these are ideal components. And on your little pop-up box you can see that there's a little voltage icon here, so if that's already selected. If I click on that, they go away. So put it back on again, you'll notice the voltages appear. Now of course there are 12 volts across the battery to ground, and it indicates that there with this 12 volts. And it's saying we have 4 volts on the right side of R1, 4 volts between that point and earth. Okay, so all the voltages reference earth, which is node 0 as you remember. Let me take the voltages off. Next one on the right here, as it tells you along the bottom, is displays current values on the schematic. So as I've moved my mouse, of course it's disappeared, but if I hover over the current again, you'll notice that little message appears there, so it's helpful. It tells you what the thing's for. Okay, so click on currents. It's giving us 8 milliamps drawn from the battery. That flows through R1 and it splits evenly because these two resistors are the same value. 4 milliamps of it goes to the left, 4 milliamps goes to the right. They join together, 8 milliamps again flowing through here, and it goes in a circular fashion. Okay, if I move over and turn the current off so I don't clutter the diagram, again move to the right, And this little bolt of lightning on there is for powers, so click on that and it's actually giving me the powers in the circuit. So PD, power dissipation, equals 64 milliwatts in R1. If I want to move these things around, I can do. First thing I need to do is get rid of the dialog box which was active, so now I'm able to move the powers around, which is useful for assignments. Okay, you can move these anywhere you want, so it's not superimposed upon your component text. Okay, and all of those things are still available to you up here. Okay, so you can see voltages there, they've come in, and currents, they're all there. So this particular circuit in its current form displays the voltages, the currents and the power dissipations, which is very useful. Okay, and that was your quick tour of the MicroCap simulator. We're going to have lots more fun in many future videos and lots more advanced circuits. Okay, this has been Mike Lopez, and thank you very much. See you soon.